Rivers don't move. That's just not how they work. A river carves its channel over thousands of years. Once it's there, it stays. You don't change where a river flows. Not with construction equipment, not with dynamite, not in a single human lifetime, unless you release 41 wolves. That's what happened in Yellowstone National Park in 1995. And what followed, what those 41 animals did, not just to the elk, not just to the trees, but to the actual physical course of the rivers, is one of the strangest, most documented ecological events of the 20th century. Scientists called it a trophic cascade, which is a clinical term for something that is genuinely almost supernaturally hard to believe. But here's what makes this story worth telling properly. The scientists who first saw it happen didn't believe it either. They thought they were measuring incorrectly. They went back. They checked again. The rivers had moved. So let's go back to the beginning. Because you need to understand what Yellowstone looked like before the wolves to understand why what came after is so extraordinary. By the early 1990s, Yellowstone was in trouble. Not in a dramatic, obvious way. Not a wildfire, not a drought, not a single catastrophe you could point to on a map. It was more like a slow unraveling. The kind of decline that's easy to miss if you're not looking for it. The kind that ecologists describe with a word that should sound alarming but rarely does. Degradation. The elk were the problem. Or more precisely, the elk with nothing to fear were the problem. Wolves had been hunted to extinction in Yellowstone by 1926. Shot, trapped, poisoned. The last confirmed wolf pack in the park was eliminated as part of a deliberate federal campaign to protect livestock, which made sense if you were a rancher in 1920. It made considerably less sense if you were an ecosystem. Because what no one fully understood at the time was that the wolves weren't just predators. They were architects. And when you remove the architect, the building starts to change. Without wolves, the elk could do something they had never been able to do before. They could relax. That sounds almost funny. But it matters enormously. An elk without predators doesn't just eat more, it eats differently. It eats wherever it wants, for as long as it wants, without ever looking up. It stands in riverbeds and grazes the willows and aspens right down to the waterline. It hangs around valleys and flat open areas because those are the easiest places to be. And it does this year after year, decade after decade, until the vegetation along the riverbanks is essentially gone. By the time the wolf reintroduction was being debated in the late 1980s, the Lamar Valley in northern Yellowstone looked like a place that had given up. The willows were stunted. The aspens were dying. The riverbanks were bare and eroding. The rivers themselves, the Lamar, the Yellowstone, the Soda Butte Creek, were wide and shallow and unstable, their banks collapsing into the current because nothing was holding the soil together anymore. It was, by any honest ecological measure, a degraded landscape, functional, technically, still beautiful, in the way that a patient who's lost 30 pounds of muscle can still be technically alive, but not what it was supposed to be. The decision to reintroduce wolves was controversial in a way that people who weren't there tend to underestimate. Ranchers near the park boundary were furious. Some senators tried to block it legislatively. There were lawsuits, there were protests, and there were serious credentialed scientists who argued that the whole project was romanticism masquerading as conservation. That you couldn't just put wolves back into a landscape that had been without them for 70 years and expect it to work. In January 1995, the U.S. Fish and Wildlife Service drove 14 wolves in plywood crates from Jasper National Park in Canada into the northern range of Yellowstone. The following year, 17 more, then 10 more in 1997 from a different population. 41 animals total, released in phases, into a park that spans 3,500 square miles. For the first few months, the biologists just watched. They had radio collars on every wolf. They tracked kill sites. They counted elk. They were waiting to see whether the wolves would survive, whether the prey population would respond, whether the reintroduction would do what the models predicted. What happened was nothing like what the models predicted, or rather, it was more than the models predicted, much more, and it came faster. Within 2 years, the elk population in the northern range had declined. That was expected. Fewer elk, less grazing pressure, vegetation recovers. Simple math, right? Except the vegetation wasn't just recovering in the areas where elk populations had dropped. It was recovering in specific places, particular valleys, specific stretches of riverbank, places where the elk numbers hadn't dramatically changed at all. William Ripple, a forest ecologist at Oregon State University, was the first person to put the pieces together in a way that changed how ecologists think about predators entirely. Ripple wasn't even looking at wolves initially. He was studying aspen regeneration in Yellowstone and noticed something strange. The young aspen trees were coming back in some areas and not others. And the pattern didn't match the elk population data. It matched the terrain. The aspens were recovering in places where elk couldn't stand safely. Steep gullies, dense thickets, narrow river bends with poor sight lines, places where a wolf could close distance quickly and an elk couldn't run. And the aspens were still dead in the open flat valleys, even where elk numbers had dropped, because an elk with a clear view in all directions still felt safe enough to linger and graze. The wolves weren't just killing elk, they were scaring them into moving. This is the concept that ecologists now call the ecology of fear. And it is, in retrospect, obvious. Predators have always done this everywhere throughout evolutionary history. But it had never been documented this clearly, in real time, in a bounded landscape, with researchers already on the ground. Yellowstone became the most closely observed experiment in predator-prey dynamics ever conducted, because here is what happened when the elk started moving. The willows came back first. Within 3 to 5 years of the wolf reintroduction, willows along the banks of the Lamar and Soda Butte Creek had grown from knee height to over 2 meters in some stretches. Which sounds like a tree fact. It isn't just a tree fact. Beavers followed the willows. By 2000, there was 1 beaver colony in the entire northern range of Yellowstone. By 2012, there were 9. And beavers, as anyone who has spent time thinking about hydrology knows, are not passive residents of a river system. They are engineers. They build dams. Dams create ponds. Ponds slow water flow, raise the water table, create wetland habitat, stabilize the surrounding soil. At the same time, songbirds began returning to the riparian corridors, the strip's dense vegetation along the waterways. Species that hadn't been seen in the Lamar Valley for decades started nesting in the recovered willows and aspens. Migratory waterfowl, raptors. The food web was rebuilding itself from the ground up, or more accurately, from the roots up. The elk carcasses the wolves left behind, because wolves don't eat everything, became food sources for bears, for ravens, for coyotes, for bald eagles. The wolf kills in winter provided critical nutrition for species that otherwise struggled through the lean months. Grizzly bear populations in Yellowstone began recovering in the late 1990s, and researchers later identified wolf-killed elk as a significant factor in their improved winter survival rates. But all of this, the willows, the beavers, the birds, the bears, is still, in some sense, what you'd expect. Predator returns, ecosystem responds. The chain of consequences is surprising but not incomprehensible. Then the rivers moved. The vegetation recovered first on the steepest, most wolf-exposed riverbanks. Those roots, willow roots specifically, are extraordinarily good at binding soil. Not just binding it, but deepening it, building it, holding it against the current even in spring flood conditions. Where bare eroding banks had been losing ground to the river for decades, the soil suddenly had structure, the banks held, and then they grew, and then they changed the shape of the channel. Researchers measuring the Lamar River's cross-section in the early 2000s found that the channel had narrowed and deepened in areas with recovered riparian vegetation. Narrower and deeper means faster flow, more consistent banks, less lateral erosion, less meandering across the valley floor. The river was, quite literally, redefining its own path. This is not a metaphor. The geomorphology, the physical shape of the land, had changed in less than a decade because of the behavior of elk, which changed because of the presence of wolves. Robert Beshta, a hydrologist who spent years documenting this at Oregon State alongside Ripple, was careful in his papers not to overclaim. The science of trophic cascades is complicated, and Yellowstone's recovery was never solely about wolves. Fire history, climate, tourism pressure, management policies, all of it matters. But Beshta's data was unambiguous on one point. The rivers were moving in ways they hadn't moved in living memory. And the timeline matched the wolf reintroduction with a precision that was hard to dismiss. The phrase that gets used in ecology papers, usually buried in the methods section, is geomorphic response to trophic cascade, which is beautiful in its way if you understand what it means. The shape of the earth responding to the chain of life. Geology changed by biology. A river redirected by a wolf. There's a question that comes up every time this story gets told, and it's a fair one. If wolves can do this in Yellowstone, why aren't we reintroducing predators everywhere? The honest answer is that Yellowstone is unusual. It's large enough to support a viable wolf population. It's federally protected land with no permanent human residence inside the park boundary. The prey base, elk, bison, deer, was already there in abundance. The conditions that made the Yellowstone reintroduction possible are not conditions that exist in most places where large predators have been lost. And the political resistance is real. The ranchers who fought the 1995 reintroduction weren't irrational. Wolf predation on livestock is a genuine economic burden on families with thin margins. The conflict between large predator recovery and agricultural livelihoods is a real conflict with no easy resolution, and anyone who dismisses it hasn't looked at the actual data on livestock losses near wolf territories. But here's what Yellowstone's did prove. Permanently and beyond reasonable scientific dispute. Ecosystems are not just collections of species, they are processes, feedback loops. Relationships so deep and so old that pulling one thread can unravel things you never expected to touch, and restoring one thread can rebuild things you never expected to recover. A wolf eats an elk. That's the part you can see. But what comes after? The fear that changes where elk stand, which changes what grows, which changes who lives there, which changes the water, which changes the land. That's invisible until it isn't. Until you go back after 20 years, and the rivers have moved, and the valley has full of birds that weren't there before, and the beavers are building dams in streams that were empty, and the banks that were collapsing are holding, and the aspens that were dying are 15 feet tall. 41 wolves. Released into what looked, by 1995, like a valley that had used itself up. What they found was that the valley hadn't used itself up. It had just lost the thing that organized it. The thing that told the elk where not to stand, so that the willows could grow, so that the beavers could build, so that the rivers could find their proper shape again. There are ecologists who spend their entire careers looking for relationships this clean, this demonstrable, this impossible to argue with. If this story rearranged something in how you think about the natural world, if the idea that a wolf can literally move a river is the kind of thing you want to carry around in your head, drop that in the comments. Not a like, not a subscribe, an actual thought. Because the people who watch this channel aren't passive. They're the kind of people who hear wolves changed the rivers and don't reach for the skip button. The Yellowstone wolves were only the beginning of the story. What's happening now with wolf populations across North America, with rewilding experiments in Europe, with the question of whether trophic cascades can be engineered deliberately in degraded ecosystems. That's a story for a different video, and it's stranger than this one. But it starts here, in a dead valley in northern Wyoming, with 41 wolves stepping out of plywood crates into the January snow, and the rivers, years later, quietly moving.